So now that you know a bit more about the half-sync, half-async pattern, let's turn our attention to how it's actually implemented in practice. And we're going to talk about how it's implemented and applied in the context of Android. And you'll see that, as is often the case, the Android concurrency frameworks that implement these patterns also themselves rely on various Java concurrency frameworks. So in particular, the AsyncTask framework, which is the Android part we're focusing on, leverages the underlying Executor framework from the Java concurrency world in order to do the thread pooling. So we'll start by talking about the overall approach to implementation. We're going to be decomposing the system into 3 layers: the synchronous part, the asynchronous part, and a queuing part. And the way you first start by doing this is by identifying operations that don't take very long to run, and then implementing them in the async portion of the pattern. If you're interested in seeing the source code's all available in the Android open source platform bundle distribution, and you can download it. It's in the asynctask.java file. It's a really interesting implementation. And you can see here that this is the main entry point into, or one of the main entry points into an async task, which is this method called execute on Executor. And this is actually a template method from the template method pattern from the Gang 4 book. And what it does is it first calls a hook method that can be overridden by application developers who subclass from AsyncTask. And what it does is it will call this on pre-execute hook method, which does stuff that needs to run in the user interface thread, maybe starting a progress bar or a progress dialog. And then it goes ahead and uses the underlying Executor service to execute a task that will do the long-running computation in the background. And we'll talk more about that in a second. So you can see here that we're going to have, excuse me. So you can see here how we're going to look at another part of the AsyncTask framework or the AsyncTask class. This is the constructor for AsyncTask, and you can see it makes a new worker runnable object. This is a good old anonymous inner class. And this is where the long duration processing is going to run. And what is cool about this particular approach is that this is going to be passed off, this M worker runnable is going to be passed off to the underlying Java Executor framework. And it's going to go ahead and run this task, this runnable, because you run runnables in the Executor framework. It's going to go ahead and run this in the background. And you can see that the do in background hook method, which is something that's provided by the AsyncTask class, that's where the long duration operation is going to take place. And that's, of course, implemented in the synchronous layer. And that runs in a background thread in the underlying Java Executor framework. And that's this call down here where it says exec.execute, that particular method that's passed in, or sorry, task that's passed in is this worker runnable. The way in which the two halves communicate to each other from the async part to the sync part is done with a blocking queue. And in this particular case, that blocking queue is something that should be very familiar to you because we've talked about this many times in the course. This is just the blocking queue interface that comes out of the Java util concurrent package in the Java util concurrent portion of Java. And a blocking queue can be a linked blocking queue. It can be an array blocking queue. I think in the case of AsyncTask, it's probably a linked blocking queue, but it doesn't really matter. It's a blocking queue. And that allows the threads that are running in the thread pool executor to basically block when there's nothing for them to do. And when there is work, the work gets put onto the queue, and then some thread is awakened using all the mechanisms we've talked about before when we talked about the thread pool executor in order to do the processing. So those are kind of the 3 layers, the async layer, the sync layer, and the queuing layer. The next thing we're going to do then is actually implement the services that we want to run. These are these long duration operations, and they're going to reside in the synchronous layer. So you can see here that we are going to define our own class, which is a subclass that extends AsyncTask, and it's going to have a method called do in background. And the do in background method, as we saw from the earlier slide, is going to be run in the background thread from the thread pool executor. And it got there because that task was what was created in the async portion and then passed when we called execute to the sync portion by enqueuing it on that blocking queue that we just saw. And so here's the do in background method, and you can see all it does is it just downloads the image that we designate to process here. Then you can also implement whatever services you might want to that are going to run in the context of the asynchronous layer. These are always intended to be very short-lived services that don't block. So some of the examples here would be the on pre-execute method, which will tell the dialog to display. If you download long-running operations in Android, it'll usually put up or if you download big files or something, it'll throw up a progress dialog that shows how far along you are. And you can do that here with this dialog, and you can say start displaying the dialog. And then there's also another hook method called on post execute, and that's called back in the context of the user interface thread after everything's done. And as you can see, what it does is it goes ahead and dismisses the dialog, so that once the image has been downloaded, we don't have to keep that little spinner going to show how the download is proceeding. So on pre-execute runs in the UI thread, and on post-execute also runs in the UI thread, because these are both very short-lived operations that don't block. And then, of course, the other thing that needs to be done is you need to implement, or in this case, reuse the queuing layer. And that, of course, is something that we get out of the box for free with the Java thread pool executor class that we've talked about many times before. And if you were to take a peek inside the thread pool executor, you'd see that there's this work queue that's used to mediate between the callers, which is the async part, and the receivers, which is the sync part. And you can see that there's a method called get task, which asks the queue for the next item by using take. And of course, that will end up blocking until there's something to do. So that's how the task gets the work to do. That's how the worker task gets the work to work on. And then you can see the execute method goes ahead and just plops the command or the task into the queue. So this is a blocking call, and this is also a blocking call. So take an offer will block. So let's take a look at how we can apply this pattern in Android. It's actually really cool. I'm not going to walk through the source code in the interest of time. If you're interested, there's videos that are on my website from other courses where I actually have walked through all the source code for the AsyncTask framework in Android, and you're welcome to take a look. It's really cool. But I'll kind of look at it more visually. So the way this works is that the user interface thread, upon receiving a URL from the user, will call the execute method on a subclass of AsyncTask, which in this case is going to be the download AsyncTask. So from the download activity, which is, of course, the user-facing portion of this app that prompts the user and gets the input from the user, it goes ahead and it executes that async task. And when you execute the async task, then several interesting things happen. So ultimately, what's going to happen is we're going to end up giving that work to a thread in the pool of threads, and that pool of threads in this case is implemented by the thread pool executor. So that kind of connects to what you've learned from other parts of the course. And it uses a blocking queue in order to pass the information over there. There's a synchronized request queue that we talked about that's used to mediate the interaction between the synchronous and asynchronous layers. And so when execute is called, that goes ahead and will first call on pre-execute, which runs this hook method in the user interface thread. For example, to start the dialog, the spinner, if you will, to show the progress of the download. Then it calls execute on the executor, and that goes ahead and plops the command that we created, this worker runnable, into the blocking queue. And then another thread will pull off the request. One of the threads from the worker threads pool will pull the command off the request queue, the blocking queue, and then it'll call or run the request. And that will ultimately involve triggering the do in background hook method, which does the long running computation, in this case to download an image, but it's whatever you decide to do. And that runs in the context of a background thread. And then when it's all finished, it'll post the result, and that ends up sending the result back to the user interface thread, which will invoke the onPostExecute hook method. So you can stop the dialog or whatever you need to do to clean up. And then the image will be available for the Android app to display through whatever means it chooses to do. So to summarize this particular discussion of the implementation of this pattern, the async task framework implements the half-sync, half-async pattern, and it does this to encapsulate the creation of background thread processing, or the passing of requests to background threads to a pre-spawned pool of threads. And it involves interactions and synchronization and communication with the async UI thread, which can't block. Another nice thing that we can do with Android is you can also report the progress of running tasks. There's another way to pass information from a background thread back to the user interface thread periodically. So the async task framework in Android is a very sophisticated implementation of the half-sync, half-async pattern. But what's so cool about this, of course, is that we documented this pattern in the mid to late 90s. And of course, Android didn't come out for maybe a decade later. So it was cool how the pattern predated the Android implementation, and the Android implementation is just a great example of applying this pattern in a good old industrial strength context. So that's the end of our discussion of the half-sync, half-async pattern. A very cool pattern used in a surprisingly large number of different contexts, and can really be useful to think about how to structure your code with a mix of sync and async communication and processing. I, of course, would be remiss if I didn't point out that modern reactive frameworks, reactive programming frameworks like RxJava and like Project Reactor go one step further, and they have the ability to do entirely asynchronous processing, as does the Java Completable Future framework. And we'll cover those topics in the next class in the next semester. So if you want to see sort of taking the half-sync, half-async pattern and injecting it with steroids to get it to be entirely asynchronous, come and take those courses, and you'll get a chance to learn about how all that stuff works too.